and welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but still want to be its friend. I'm your host. I'm Dr. Moiya McTier, an astrophysicist, a folklorist, and obviously a good friend to the universe. I'm recording today from my office here at Pale Blue Podiversity, and I'm expecting a stellar guest to talk about a recent trip we both took to one of NASA's centers. It's NASA Goddard outside of D.C. I'm going to be joined by Eric Silver, who is a writer, a teacher, and the best game master in podcasting. And he should be here any minute now.
Oh, hey, I just came from the creative writing and podcasting wing of Pale Blue Podiversary. Hi, Moiya. I'm so glad that you're here in your office hours.
Thank you. Yeah, I mean, I love having people come and see my office and sit on all of the plush ivory tower seats that I have.
Finally, Pale Blue Pod of University. I keep saying it like it's Pale Blue Pod Anniversary. Pale Blue Podiversary. I'm so glad that you finally got into the Ivy League and we decided all to kick out Dartmouth. That was really smart.
It's actually in the Nightshade League. Pale Blue Podiversity plays in that sports league, yes.
That makes sense. That sounds like you compete against like witches colleges and stuff like that.
Yes. Did you not see them competing in potion making and spellcasting on the quad?
Sure. Yeah, long-time rivalry with Bard University.
Love adding to the Podiversity lore here. Thank you so much, Eric. But before we get into the NASA of it all, I would love to ask you some get-to-know-you questions. I've known you for a few years, but these are things that will really get at the core of who you are as a person.
Sure. Yeah, let's do it.
Fantastic. Starting off nice and simple, Eric, when you think about the vast, vast universe, how do you feel?
You know, for a long time, I was just like, you know what I care about is like humans and the Earth and like the things that we do, the anthropology of it all. But man, we've been beefing it lately. So it's kind of would be nice to think about like celestial bodies instead. Space kind of freaks me out, but honestly, Earth isn't doing better. So I'm just kind of getting over it.
Yeah. Look, I am very soothed and comforted when I think about space, especially compared to the dumpster fire that we're living on right now. So I'm there with you. Okay, this next one is a bit lighter, perhaps. What's your favorite unit of measurement?
Oh, great question. I've been super into grams lately. Grams is super underrated. Especially with us being pound-centric and ounce-centric. I have been doing a lot of, not baking, I guess, doing ice cream making lately. I have an ice cream maker, and it's kind of adjacent to...
Ice.
Nice ice. It's adjacent to like the science of baking and how much you have to use a scale. So I use a scale a lot, actually, and... especially figuring out the fat content. It's pretty sciencey. I'm loving my scale, and I just love how 100 grams feels like. I'm like, that is 100 grams of turkey. I weigh other stuff too now, and I'm just like, you're right. That is definitely what this is. Shout out to grams.
I love how you're testing the scale. You're like, yep, that is 100 grams. Good job, scale. Eric, do you feel like your sun sign in the zodiac fits who you are as a person?
That's a really good question. I do, with a caveat. I am a Taurus. It just means I like not doing stuff and being under blankets. I never really understood why it was in the spring. Because that's like the beginning of not being under a blanket weather. And I always try to figure that out by having a lighter blanket and being under a blanket with more air conditioning. But it's like May is usually the time that shit kicks off.
If I had to guess why that association happens, I would say it's because babies born in May in the spring are born during times of plenty. They're coming to their like form in times of plenty, and so they can be kind of spoiled in a way.
Sure.
That's what I would guess.
No, that works. I only know enough astrology to like keep up with the bisexual women in my life.
Oh, then you need to know way more than just your sun sign, my guy.
No, they'll tell it to me, Moiya. That's the key. I'm like, hey, ladies.
That's the trick. Hey, ladies, I'm just a dumb boy. I don't know anything. Teach me your astrology ways.
I'm such a dumb boy. I have emotional intelligence. Help me, please.
Help me, please.
Help me.
Well, I'm glad that the sun sign at least superficially fits. Actually, I'm not glad. I would like to meet more people who don't feel like they meet their sun sign. So listeners, I'm putting out this call for the first time. If you don't feel like your sun sign fits who you are as a person, please let me know, because I need more examples of that. The next question I have for guests is, what event in space would you most like to witness, assuming you could be perfectly safe? You can travel through space and time.
Oh, I would love to ride a comet. I think that would be neat, like a space cowboy.
You're the first to really interact with the thing that you're going to witness.
Yeah, because it's I don't have a specific event I want to see other than the formation of stars and planets and stuff. But it's I more want to be a space cowboy in the NSYNC sort of way.
Nice. And do you want to pick the comet or just be randomly assigned? Halley's is nice.
Halley's is obviously the one that's the classic, but I don't really I don't care. It could be anywhere doing whatever it's doing. I could also Dr. Strangelove, the comet that hit the Earth and wiped out the dinosaurs too. That could be pretty fun.
Yeah, so you could see it in real time.
Yeah.
So save a horse, ride a comet. Word.
Yeah, for sure.
Well, when we're launching you to reach your comet out in space, you are in charge of the playlist in the rocket. So what are you playing when you blast off?
Oh, man. Oh, that's a really good question, Moiya.
I've been doing this for a while.
Yeah, no, that's good. I have so many different thoughts about this. As long as it's a banger, it would be fine. The one that I always say I would walk out to, baseball walkout song, would be Tradition from the Fiddler on the Roof. In the part where all the mamas and the papas and the sons and the daughters all sang at the same time in the medley, that would be sick. And now I'm imagining similarly, it's watching the rocket blast off. Any song would be a banger for it, honestly. I've been listening a lot to Femininomenon by Chappell Roan lately because I really like it, but it's such a funny song, and I think it's set up like it, where only the chorus is the sick beat part. So it would be really funny if the rocket was about to take off and then Chappell Roan say, "Can you play a song with a fucking beat?" and then it goes. I would really like that.
Yeah. That's good. All right. Wow. I know you so much better now, Eric. I know about you and Grams. You and your desire to ride comets. The whole Eric picture is really coming together.
Yeah. When I did my my bachelor party, my friends organized a whole thing in upstate New York, all surrounded by games, and we got a steak dinner. And we played laser tag. And the whole time I was I'm so glad that I have such definable hobbies that you were able to put all of this together, And I feel listening back, thinking back of what my answers were, I'm yeah, that are all answers Eric Silver would say. I hope you knew me better, or it just kind of deepened what you already knew about me. It was more you were doing a scientific trial, and it's yep, we can release this medicine. We got it.
Exactly. Yeah. Which of these was the control question?
Right. It was grams. It was the thing about grams.
It's always about grams. Okay, well, thank you for going through my questionnaire. Now I want to get to this NASA trip that we took in late February, and it didn't come together super quickly. So what happened behind the scenes to make this trip go on? Yeah,
so I ran into NASA at a podcast convention. It was in Podcast Movement 2024 in D.C. I think if I'm looking at my calendar correctly, it was July of 2024. So it's been a while. We ran into the folks there. They have podcasts there, and we're hey, we'd love to do something together if you want. And they're yeah, what a great idea. And then, of course, it moved at government speeds before, and then slowly it started coming together. Now, I don't know if you remember, but some things changed in November 2024.
What?
And it was oh, I guess, do you still want to do this? And just talking, having meetings and trying to plan stuff in the kind of transition of the Biden presidency to the Trump presidency, just the kind of sense, the creeping dread was around it. But, it's I was really excited to do this. NASA rips. Space rips. It is a universally accepted fact that NASA rips. And
that is so interesting to hear.
Yeah.
Because that's what people who aren't astrophysicists think.
Well, I that's what I'm saying. This is why the whole thing was strange to me. It's the American public thinks NASA rips. You can buy the amount of branding that NASA does with clothing brands and toys and Legos and stuff like that. I'm like, the American public thinks going to space and the people who do it are cool. So I think it was more as things changed. I'm like, I don't know what to do. I'm excited about what we're doing, but everything else means like we can't be excited.
Yeah. And that was definitely in the air when we went to visit. Yeah. We had this kind of tense pre-planning call with them where we were trying to figure out what to talk about during our NASA podcast day.
Yeah.
And it was like a cloud over the visit. And I want to talk about that later.
Sure.
Yeah, I don't want that to color what people hear about the visit itself, because the visit itself, when we removed it from the bigger context, super cool. Like, we saw some very cool things at that NASA center.
Yeah, you're gonna have the words for it, but the whole time I'm like, wow, everything's huge, everything's wild. We got driven around the campus, we saw a bunch of stuff. We got spiels from scientists, which were really fun. But yeah, it was just like, it was a weird, like everything, it was just kind of a weird time.
It was a weird time. Yeah, I was taking notes on our tour, so I want to revisit that. We started at the Visitors Center, and it had some standing exhibits and some new ones that cycle in and out. There's an exhibit about the sun, an exhibit that I think is new about the different smells of nature. And I remember seeing this at the American Astronomical Society meeting in January, where they have these different scents. One smells more like grass, and then another smells kind of like ozone and the sea. And they're supposed to represent different ecosystems and potentially different exoplanets. So you smell them and you try to identify it. And that was really fun.
That was cool.
And they had to build a planet one. Do you remember that? We saw it right at the end and tried to start it. We tried to start a world building thing, and then we had to go.
I know. And they were like, get on the bus. And we're like, no, we just found something we're interested in. Help us. Let us do it.
Let us do it.
We want to see what oozes we can make on this planet.
Yeah, I want to know what different features that we could have played with. But I think we only got so far as selecting a gas giant planet around a pretty small star.
Yeah.
And then we had to go. But that's okay. That's a world-building exercise we can do another time. We then went on this tour of their facilities, and they have clean rooms where they build and analyze telescopes. They have facilities where they test all of these telescopes. We started off with a tour specifically of like the Nancy Grace Roman telescope section of NASA Goddard. Had you heard of Roman before we did this tour?
No, I had not.
Okay. Yeah. Well, they gave us a little information session, and I was not paying attention during the information session because I knew all I don't think anyone there knew that I was an astrophysicist, actually.
Yeah, that was the other thing, because like we also, we have so many doctorates in science at Multitude. So I was like, I was there as an idiot, and Amanda was there, and Brandon like loves space, and then there was you, and Sam was there, who is also Dr. Science. So it was just like, I'm like, I'm just out here vibing. Like, I'm just vibing here. You can do the speech at me, but I want you to know that other people here know what they're talking about.
Right. Like, that's the standard tour that they give groups who come in to learn about Nancy Roman, and that is not tailored necessarily to the different audiences. So we got that little info session, and then we went into the observation deck where we could see into the clean room where they were cool. Yeah, they were holding the telescope, and it's not all put together. It was in its separate pieces, covered in plastic, in this white room where everyone's in these white suits. And the tour guide said that it was a class 10,000 clean room. Do you remember that?
Yeah, that was because of all the HEPA filters. Like, it was like you walk into a warehouse or like an airplane hangar, and then imagine like 3 stories of a wall. A 3-story wall was all HEPA filters. That was crazy.
Yes. And the air always moves in the one direction to take things like towards the HEPA filters. And like the air doesn't circulate. It moves in a direct motion.
Wow.
But I went in and did some research on the different clean room classifications. And apparently this 10K class is the second dirtiest class. that they could have. It goes from 100K to 1. Yeah. It's just, like when the tour guide said it, she made it sound like this is so impressive. This is the cleanest thing ever. But the classification system goes from like 100,000 up to 1. Mm-hmm. And that tells you how many particles of a certain size can pass through the filter.
Got it.
And so this is, it's clean, but it's not the cleanest.
Yeah, there was something about it also. Everything was white. I think NASA's just really good at making things look the way that they should. So and I know that they need to all be in the bunny suits, but it really looked science-y because they were all wearing like the clean room suits.
and yes, they do need to be wearing them, but it also is some very fun theater. It's practical theater.
Okay, I wasn't sure. I mean, I was definitely wowed by it, though.
No, it's wowable.
Okay.
And so are the other things. So they have that clean room, which, by the way, medical clean rooms developed for astronomy because we like to keep our telescopes free from dust. And apparently that's also good for, like, when you're operating on people. So we saw the clean room. We went to this sound testing chamber.
Oh, yeah.
This giant room with these heavy doors where you can generate sounds up to 160 decibels in the room, and it's dampened so other people don't hear it. And that plus this other tool, like a shaking table that they use to make sure instruments can withstand vibrations during launch, because loud sounds will create vibrations and the like force of the rocket moving will create that. So they need to make sure that instruments don't fall apart.
Same, me too.
You spent some time in the big sound room. What was your impression there?
I was that the one with all the tubes in it?
Like with the cones.
Yeah, with the cones. I mean, everything about sound I think is so funny. I just like to immerse myself in places. I'm like, I ostensibly work in audio art, you know what I mean? So it's like, it's just fun being in a place like that. I'm like, oh, podcast, me. Yeah, for sure.
Absolutely. Yeah, they have so much cool stuff going on because space is an extreme environment and you need to test things here on Earth, which is a much less extreme environment. So they have these thermovac chambers that get up to super high temperatures, the temperatures that you might experience if you're in direct line of the sun's heat. They can test the instruments for temperature exposure, but also eliminate any unwanted molecules or compounds or like tiny little organisms that are living on the outside of the instrument.
Yeah.
We also saw the Hubble control room, which was pretty cool. Apparently that used to be monitored 24/7, but now it's automated. It sends the PI and the other Hubble team members a notification when there's an issue or there's something interesting that needs to be checked. So it's all run on little beepers, essentially, which is so fun.
There's a meme where you can try to run the video game Doom on any piece of equipment or any piece of technology. You can run it on on a refrigerator, the computer in a refrigerator. You can run the video game in inside of a PDF. Some people have even hacked a pregnancy test to use the screen to run Doom on. But the entire time looking at the Hubble control room, I'm like, can you even run Doom on this? What is going on? It was one crappy computer. It was wild.
Yes. Yeah. I mean, Hubble was launched in 1990, I think, but it's old. And the technology used to make and maintain it, it's out of date now.
Yeah.
Really out of date. It looks so out of date, in the control room itself. And then around the control room, they have essentially little museum exhibits to showcase other, even more out of date things and the really complicated ways they've solved problems. They had to go up to Hubble. They sent human beings up into space to fix the Hubble telescope after it launched. And they had to deal with these tiny little screws and these big circuit boards that need to line up just right. And so they didn't want the humans to have to deal with all of that dexterity stuff out in space, especially when they have all of their gloves on. So they developed tools like a drill that would hold the screw in place and then capture it once the screw is unscrewed completely, or this box that you can just place down on Hubble, for example, and it lines up the circuit boards for you. And it's nice to see the ingenuity there. Yeah,
the whole time I was thinking, wow, it's really easy to do one thing that makes you die in space. That was the whole time I was dealing with this, and they're trying really hard to make sure that doesn't happen. But I think that the tour guide for the Hubble was so self-assured and had done that speech 5,000 times that, like, it didn't really, I don't think it gave us space to, like, reckon with the fact that how crazy everything he was saying to us. And, like, that they invented all of these things to make sure that astronauts are safe and how many things they invented.
Yeah, I feel like that information should be presented with a certain gravitas.
Right.
And he was so casual, so nonchalant about it that, yeah, we didn't have time to fully appreciate it. Other tour guides were fantastic. We had this great tour guide named Janet who showed us the thermovac chambers and this giant 100-foot-long centrifuge.
Oh, yeah.
And she also had us act out. She had you, Eric, act out like the different times in a telescope's orbit around Earth where it would be exposed like to the sun or something.
I know. I think I was the sun.
Fun.
Or no, I was the telescope because I kept spinning around. I was something that was in orbit. I couldn't remember what it was.
Yeah, so she was great. Janet was fantastic.
Yeah.
If anyone from NASA is listening to this, Janet deserves a raise and a plaque with her name on it everywhere.
Yeah. We were in such good hands with her. It was like we could ask her literally anything and she would have an answer for it. Like it was incredible.
Yeah. I also felt like I was in very good hands with the guy who drove our tour bus around the little NASA campus.
Oh my God, that was so underrated. That was incredible. So you have to remember, okay, so we're on a minibus. It is white and NASA branded, coded, and there's just, and you know, we've all been on field trips. You respect the bus driver because the bus driver is getting you place to place and knows where things are. What we learned was that they measure like 5,000 times because there's so little clearance for them to get the telescope from where they were assembling it in DC and take it to Cape Canaveral or wherever they're launching it from. And it's like, oh, well, they got to put it on a truck. And it's very, very precise. And it turns out that the guy who drives that truck was just the guy driving our minibus.
Yes.
Who had like
And
5 presidential commendations.
Yes, that part. He was such an accomplished driver, and he was spending that random like Tuesday afternoon driving us around in this bus, where previously he had spent 16 hours, not just like driving the thing on a road, but he spent 16 hours parking the truck into a hangar to hold the telescope with like a few inches of clearance on either side. Can you imagine having to take like a shift break in the middle of parking a truck?
I can't even imagine that he did. He's doing it for his country. He's a hero.
He is a hero. And he was so chill about it all too. So shout out to that bus and truck driver.
We found out like 3 activities in and we found out somewhere else. And then we came back to the truck and we're like, you're a hero. And he's like, nah.
Hey there, friends. Eric went outside to practice spells with the students on the quad, and while he's gone, I want to share some messages with you. First and foremost, I want to say thank you to all of my patrons who support the show every month. I couldn't make the show without you because it costs money to make a podcast, and I'm an indie show, so any support is super valued, which is why I want to give a special huge thank you and shout out to my Sun-like stars, Scott Reynolds, Augustin, Tom T., Mark Mahoney, and Knicole Bartlett, you golden, beautiful, stellar children out there. If you would like to support this indie podcast on Patreon, you can hear your name on the show, you can make it to my patron star chart, and get research notes for most episodes for $5 a month at patreon.com/palebluepod. Of course, if you can't support the show financially right now, that's okay. I understand, and you're still space. That's actually not the best way to help the show grow. The best way to do that is to get more people listening to Pale Blue Pod. I'm going to be real transparent with you. I regularly get about 2,000 downloads per episode, a little bit less than that, actually. And if we could get those numbers up, I would be so happy, and I could, do things to improve the show and make it smoother for all of us. So if you want to take a link to a favorite episode of yours and share it with a specific person, I would appreciate that forever. So thank you in advance. Next, I have a podcast recommendation for you. It's another show in the Multitude Collective, and it's called Attach Your Resume. This is a new show from Multitude that interviews online creators about how their jobs work and how they got there. You can hear the personal stories behind seismic events in digital media and learn what concrete steps we can take to build a sustainable media landscape. Attach Your Resume is the show that proves that the best credential for deciding the future of media is actually making stuff. Who'da thunk it? Season 1 is available to marathon now, and they're working on Season 2, so subscribe to Attach Your Resume in your favorite podcast app. This is another show that Eric works on, so I'm gonna, brag on it while he's gone. Oh, but it does look like he's back, and he did not, in fact, master the walking through closed doors spell. That's okay, Eric. I haven't mastered that either. But let's get back to our chat. There are really cool people like that working at NASA. There are brilliant minds. There are hilarious people. There are very talented people.
Yeah.
I had the chance to sit down with one of them. I talked to Dr. Knicole Colón about her experience as a NASA operations project scientist, because I've talked about NASA missions here on the show so many times, but I wanted to get a better sense for what happens behind the scenes to make those telescopes work. I'm joined today by Dr. Knicole Colón, and I'm so excited to be here with you at NASA today. Can you tell us a bit more about yourself? Like, how did you get here?
Yeah, absolutely. It's great to see you today. Happy to be here. We're at NASA Goddard Space Flight Center in Maryland, and I've been here actually 8 years already. Ooh. Time flies. And previously, I worked over in California at NASA Ames Research Center. So I've been with NASA for about 10 years and working on different missions, which I think we'll talk about today. Yeah. But before that, I always loved science as a kid and math and basically everything. Mm-hmm. And so, nerd. Yeah, exactly. I love the stars. And I loved the idea of finding aliens. And so that was something that spurred my interest in astronomy in general, was studying other planets. And so long story short, I went to school for many, many years. I got my doctorate degree from the University of Florida. Cool. And then spent some time doing research before joining NASA.
Oh, nice. Yeah. What did you study? What was your doctoral research on?
Yeah, it was actually using this telescope in Spain, which was amazing, and then the Canary Islands, called the Gran Telescopio Canarias. And it's actually one of the world's largest optical telescopes, so it sees visible light. And I used it to study planets around other stars, but I was looking at planets that we didn't quite know if they were real planets yet. They were discovered by a space mission called Kepler, and they were candidate planets. Yeah. And so I was trying to confirm, okay, they're actually planets. They're not like another star orbiting a star. They were a planet orbiting a star. And so I used a telescope to help confirm some of these planets, but then also to study some of the atmospheres of planets. And so my whole dissertation was about finding planets, but also what can we learn about their atmospheres.
Oh, very cool. Yeah. My dissertation, or part of it, was also on planets, but looking at their surfaces. Awesome. So it's like we've kind of tackled two ends of the habitability problem.
Yeah.
That's
Love
awesome. Yeah. Okay, well, I want to ask some get-to-know-you questions before we get into the kind of meatier stuff about NASA missions. Just a couple, and they're a little wonky. So just tell me the first thing that comes to your mind. Since you have worked on different types of missions, you mentioned optical wavelengths. If you could see in any wavelength range besides the optical, what would you choose and why?
Oh my gosh. Oh, that is a really cool question. Okay, I guess I have to say infrared right now because that's a big part of my life, looking at telescopes that I use right now. But infrared light lets you see like heat coming from distant stars, galaxies, what have you. But even it's almost like having night vision, being able to see in the dark. And so I think that would be really cool to have that capability.
I agree.
Yeah.
Yeah. I personally would go radio, but I think are you like contractually obligated to be into the infrared right now?
No, it's just, my where my heart is.
Okay, great.
Yeah.
Okay, well, I want to know where your heart is in terms of like measuring things. Do you have a favorite unit of measurement?
Microns.
Okay.
Does that count? Okay.
That counts. What is it about microns?
So this is, I guess, the nerd in me again with, liking the infrared. That's how we kind of classify the infrared wavelengths we're looking at in terms of microns. So it's a length of an infrared wave, but we use microns because that's just the easiest way to think about it. So, I can tell you, there's water absorption features that we can see in distant planet atmospheres at 1.4 microns, And so like my brain just automatically thinks in microns.
Interesting. That's very cool. Okay, I feel like I know you a little bit better now. Thank you. So we can get into the NASA missions of it all. I'd love kind of a big level idea of like how many missions does NASA even run at once, and what do they look like?
Yeah, that's a really interesting question because there's so many flavors that, like, so many ways to answer that. So I'm an astrophysicist, but NASA has astrophysics missions. They have earth science missions. They have heliophysics missions that study the sun, and then planetary missions that study everything else in the solar system besides the sun. And so there are so many layers to that question because we have missions, like a fleet, we call them, of missions that are currently operating at covering all kinds of wavelengths of light, from ultraviolet to X-ray, and everything in between. And the goal is always to learn as much as we can about the universe, every aspect, right? But the reason it's also hard to answer the question is because there's a lot in development right now. And so that's always the case because we have, what's state of the art flying in space right now, or things land on Mars and all that. But there's always new technology and ways to improve the state of the art constantly. So that leads us to, the next fleet of missions that are in development. And so the number fluctuates just because it all depends on, where you are in the year, I guess,
right,
as to what's operating currently. So yeah, I don't even have a good, a direct answer to give you on that. But that's the exciting part is, there's so much going on here that allows us to really push our knowledge, right, every day and study everything, again, from the Earth's surface even, to the moon's surface, and then the furthest, stars in the universe.
Yeah. Yeah, they really cover all the wavelength ranges. It's not just all telescopes too, right? Like there are other things that NASA maintains.
Yeah. So thinking of, I mentioned, like landers on Mars, and then there's facilities on the International Space Station, like instruments get installed there by the astronauts and, study different wavelengths of light from there. And so, yeah, it's not just, telescopes necessarily, even though that's my background. So that's where I go to first.
Right.
Yeah.
And that's what I love. And that's what Pale Blue Pod listeners love. But another point that you made there that I want to highlight that not many people realize is how long the development phase is. So we don't have to go into the development phase, but I think it's really important that you said a lot of the missions that are technically active right now are in development.
And there are different timescales. It all depends on the scope of the mission. Like I'm involved in one class of mission that's actually from concept to launch about a 5-year timeline.
Okay.
So that's pretty rapid. And that's the idea is like, we actually can and are doing, science on all different timescales. And so that's what, makes it just really exciting, again, because, every day there could be a mission launching. I mean, there was a mission launched yesterday and then something else launching later this week,
Oh, wow.
And so there's always something going on.
That's really cool. Yeah, you said 5 years. And in my head, I was like, wow, that's so fast.
Yeah.
I imagine a lot of people listening might have gone 5 years. Surely it only takes like a week to build a telescope. But no, it takes a long time.
That's right. Yeah. And the reason for that is because, we have different capabilities. Like if you want a camera, or we use spectrographs a lot, which measure like different wavelengths of light. And, you want to do careful testing and make sure it's calibrated. So, here on Earth before you launch it in space. And then you have to put it all together with the actual telescope, whatever that telescope may be. And so there's a lot of moving parts, literally and figuratively that have to come together to, robust testing of everything before you launch to space. And launch, is it's an energetic activity. So you want to
literally and figuratively
make sure that, everything goes smoothly. And so, there's a lot of work done to make sure we can get that successful science in the end.
Yes. And I'm so glad that work is done. That's part of the reason a lot of NASA missions are planned for like 5 years and then they end up lasting 10 or 15, which is incredible. I've really enjoyed seeing a lot of the different testing procedures that go on while I've been on the tour today. So I want to dig into your background and your experience with these missions. What missions have you worked on and what have your roles been?
So I mentioned, I study exoplanets, and so that's where some of the first missions I worked on focused. So I worked on Kepler for a few years.
Then thank you.
Yeah, Kepler is amazing. I mean, it let us know that, basically every star on average has a planet. But again, that doesn't mean every star has a planet, right?
Yes.
But
average
on average,
is a key word.
Yeah. So some will have none and some will have more than one. But that was revolutionary. And after Kepler, I joined what's called TESS, the Transiting Exoplanet Survey Satellite, which is basically a follow-on to Kepler, to study all the planets and look for planets nearby. So all around the whole sky, what are the closest planets that exist to us? And my role in both of those missions was basically, think of it like science support. Like if you want to use data from those missions, how do you do that? You ask the help desk, and I am the help desk, So that's kind of like how it was. I could answer user questions, help point you to where data is in the archive, how to look at the data, download it. If you want to study a certain star, I could help you with that. And so it's a lot of help desk and then, interfacing with the community and meeting the science community to learn like, what science do they want to do with these missions that maybe was not already happening? And could we make that happen?
Okay, so the community of astronomers who are already kind of into this work a little bit.
Exactly, yeah. So they were like, oh, I know Kepler, and I know it was designed to study planets, but maybe I want to study supernovae explosions, things that go, bang in the night. Like, how do I do that? And so we could help or encourage them, to find ways to do that.
Very cool.
Yeah.
That's a super necessary role because I remember what it was like to be a young astronomer sitting in front of a brand new data set for the first time, or even trying to learn how to download the data set from some sort of online archive. And so the help desk people were instrumental, I'd say, in my research.
Yeah, thank you. Yeah, I mean, that was a big part of, everyday life was helping the community. It was a service, and I really enjoyed that. And so, that was my first experiences at NASA were Kepler and TESS and user support. And it was really fun meeting everybody in the community outside of exoplanet scientists too. I got to meet so many people over the years. And then I've worked on several other missions since then as well. The Hubble Space Telescope and James Webb Space Telescope, which are totally different because they're designed to study the entire universe, every aspect from the solar system to, again, the furthest stars. And for those missions, I've had a couple different roles, but the common theme is that I would basically oversee operations, but from a scientist's perspective.
Okay.
And so I can get into that if you want.
I would love to. Could you first say, what are the other perspectives that you could consider operations from?
Yeah. So, I mean, there's engineers, there's overall project management, there's financial perspective, scheduling.
So many lenses.
Many different lenses. But being a trained scientist, my role was to serve as a person who uses the telescopes to do science, so I am a scientific user, but I also kind of help with understanding the big picture, if you will. What is the big scale ideas or projects going on with the observatories, and what else could we use them for? Kind of going beyond what they were designed for, because all these observatories exceed their requirements. They all work better than, than required.
Yeah, they're like Swiss Army knives.
Yeah.
You have no idea how far you can actually push them.
Yeah. And so we know we have certain capabilities. We can do state-of-the-art science. And so we're like, okay, this is fantastic. And so while we have this facility, what else might we be able to do, right? And so my job has been a lot of that, big picture, stepping back, but also in the weeds of knowing what it's like to use a telescope as a user.
Yeah. So you understand it from both sides.
Yeah.
That's great.
Yeah.
Thank you for that. What other roles would you say are involved in a mission that people might not know about? I think people understand that there are the maybe engineers who build the physical telescope, and then there are the astronomers who I think they imagine look through the eyepiece of the telescope and collect data, which isn't what we do, but there are astronomers who analyze the data. What other roles are necessary for these missions?
Yeah, it's almost like construction crew on a house. You need an electrician, you need someone to install the roof, you need all these factors to come in together. And so, yeah, we have tons of engineers, like you mentioned, and scientists who are actually using the data. But there are people who need to oversee, day-to-day operations, management activities. So there's project managers, making sure that operations as a whole are flowing. And this might sound redundant, but an operational perspective versus the science perspective, Yeah. And so there's also communication specialists that think about, okay, how do you, take what the engineers have done and communicate it to the public in a way they understand that's really valuable to make sure people know what NASA's doing, right?
Yeah, I love those folks.
Yeah, exactly. And so there's that. There's, people who track the budget profile, and the schedule, I mentioned before as well. So it's a lot of management to make sure that during the construction phase first that everything's going well. And then during the operations phase, if there's anything that comes up, or ways we see to, again, augment the capabilities of the observatory based on it's what we say in-flight performance,
right.
Then that's something that, the managers provide one perspective and then the scientists provide one. And then we work together to make it happen,
Awesome. Yeah, I imagine it has to be a massive collaborative effort.
Definitely.
To take these things off the ground.
Yeah.
In your scientist operations specialist role, what is your favorite thing that you get to do?
Yeah. So it's interesting because it's very easy to be in the weeds, right? Like you said, you get focused on one specific project. I have my own personal favorite exoplanets, that I like to study and things like that. Okay. And so it's very easy to get focused on that. But I like that my roles at NASA forced me to look at the big picture, for one. And so step back and get outside of exoplanets and look at, what are we learning about how stars are forming or how galaxies are forming or black holes, how does supernovae happen? I like that my job enables me to cover all areas of science and really, not just be aware of what's happening, but know what is the next step we might take, and just get to engage with all kinds of people in the community. And so I really like that variety of activities. And basically every day can be different with this type of job.
That's awesome. Yeah, it's interdisciplinary. It's new. And you get to stretch your skill set, I imagine, a lot.
Absolutely. Yeah. I was trained with your PhD, right? You are trained to do science and, maybe some other activities, but I've learned a lot being at NASA and getting to work on missions in different roles. Yeah.
Okay. I wasn't planning on asking this, but I can't not after you just said that you have some favorite exoplanets.
Yes.
So what's your favorite exoplanet?
Yeah. Well, in general, I like things that are not found in the solar system because I'm like, how did they get there? Right.
Yeah.
And it's just amazing when we have, 8 major planets here and they can be very different. And so it's fascinating to see things that are even more extreme outside the solar system. And so one of my favorites, it's a planet called Kelt 11b.
Ooh.
Yeah. The naming scheme, we don't have to talk about naming schemes, but
I've made enough fun of astronomy naming schemes on the pod for everyone.
Yeah, it's based off a survey that I was involved in, which I'm proud of. But Kelt 11b, it's basically this really low density planet. So it's very puffy and it essentially has the density of styrofoam, if you can imagine that.
Ooh.
And so that I'm like, how does such a planet like that exist, right? And it orbits a star that is basically a lot older than our sun. And so it's just a very different environment. And I'm trying to understand, what is going on with this planet and how do we get such planets like that? Because we know of a few other that are similarly puffy, we call them, but there aren't that many. And so it's really fascinating to think about how they exist.
That's way less dense than Saturn.
It
even,
is.
right?
It is. Yeah. And so that, again, like we have Saturn as an example. Like, oh, yeah, Saturn's the lowest density planet in the solar system. But this is like an order of magnitude less dense, and like more puffy. So, and we don't know if this one has rings. Probably not. But, it's too close to its star. But that's a fun one. And then there's a few planets we know of that are so close to their star, they're literally disintegrating.
Yeah.
And those are a lot of fun. So K2-22b is one of those examples. And the rocky materials basically breaking off of the planet. And we're trying to measure what that rocky material is from, I can't even tell you how many light years away, Like it's just crazy that we can do that.
I love that so much.
Yeah.
My favorite exoplanet is basic. It's Kepler 186f.
Oh, perfect.
Right?
Yeah. Well, my colleague here at NASA discovered that planetary system. So, yeah. And now I'm working on, I didn't mention this mission by name, but I'm working on the Pandora mission.
Yeah.
And that's a dedicated exoplanet mission as well to study atmospheres. And that is right now expected to launch later this year. So that's one of these that's like the short 5-time scale development. And we're, on track. We're really excited about it.
Very exciting.
Yeah.
Okay. Yeah. I can't wait until that launch. I will be setting my calendar to it for sure.
Awesome.
Nice. Okay. So that was a quick little tangent. Thank you for indulging me. We can get back onto the NASA mission track because I do kind of want to know what it's like to work on different missions. I'm sure that they all require their own approaches, but I'm wondering what about the mission itself is the most salient factor in those different approaches? Is it like the wavelength that you're observing in? Is it if it's a space versus ground-based telescope? What makes the most difference?
So space versus ground, yeah, that's a huge difference, of course. So there's a lot of radio telescopes on the ground, for example, so many amazing arrays. And so those are designed in such a way that they can, measure things like looking at stars for disks of material around them. And, that's just one example. But they are very powerful at a certain wavelength radio, obviously. But then, we have then space observatories will complement that. And we can then, let's say, look at those same disks in the infrared around those stars and learn different materials and learn like different compositions of the disk and just kind of put the whole story together between the radio and, other observatories. But I will say, so there's certain missions that are definitely you need to take unique approaches with, right? Like I'm thinking of like the Parker Solar Probe was designed to study the sun, but like we use the phrase like it was designed to touch the sun, like the outer atmosphere, right? Yeah. And so it had to be designed to survive extreme radiation and heat,
That casing is crazy.
Exactly. So that's, one example where you need very particular operational strategy to get it close to the sun in the first place, but also, be able to take measurements and from there and record them and send them back to Earth, right? But then something like the James Webb Space Telescope that's designed to study some of the first light from galaxies, it actually needs to be really cold in the infrared, right? And so that's why that had to be designed to orbit 1 million miles away from Earth, firstly, right? But then it also has this like 5-layer sun shield to keep it very cool. So basically any heat from the sun won't reach the telescope. And so you want to measure, if you really want to measure like the tiniest heat thermal emission signals, you need to not have extra heat anywhere. Yeah. And so that was very carefully designed to operate in such a way that, it stays very cold away from Earth because Earth is warm also, right? But then other things, it's okay. Like Hubble has orbited around Earth, for 35 years almost now, which is, amazing. And that didn't need to go out 1 million miles away from Earth because it covers ultraviolet and optical wavelengths mostly that the Earth doesn't really interfere with those measurements. And so, it was fine for it to orbit Earth, but also to be serviced by astronauts, back in the day.
Right. So many things to consider.
Yeah, there really are.
Interesting. Have you ever been involved with a mission from the beginning like that? So you were there when they were considering those things?
So yeah, I would say the one example I have of that is actually this Pandora mission. It was a concept, when I joined the team. Basically, we literally have like a napkin with the concept on it. And we have a picture of the napkin for posterity.
That's amazing. That needs to go in a museum or one of these exhibit cases.
Exactly. Because at the time, it was just kind of coming out that, we study planets and a lot of planets that we study now are around small stars because they're just the easiest to access right now from distant telescopes. Like if a planet passes in front of a small star, it causes a big dip in light, right?
Mm-hmm.
And so if that planet then has an atmosphere, that atmosphere, like the relative ratio, the atmospheric signal is reasonable enough for us to detect from our telescopes that are around or near Earth compared to like something around a sun-like star. But the problem with the smaller stars, we call them M-dwarfs, right? They're cool, like temperature-wise and cool, like in general.
Again, literally and figuratively.
Yeah, exactly. They are cool enough that they have water in their own atmosphere sometimes. So if we're trying to find water on distant planets, but the star has water, that's a problem, right? And so Pandora is designed to study stars at both visible and infrared wavelengths at the same time. And so we're trying to disentangle, what is happening on the star, like star spots, flares, things like that, just like our sun has. But the problem is like exacerbated with these cooler stars. And then we're simultaneously looking at the planet's atmosphere with a spectrograph. And so anyway, this concept was thought of when basically a paper came out saying, yeah, this is a big problem, and I have some very clever colleagues here at Goddard, who were like, oh, wow, we should think about putting a mission to help solve this problem,
Yeah.
And like, how do we optimize our observations to remove the effects of the star from the planet atmosphere signal, essentially? And so that started on a napkin, and
as the best ideas always do.
Yeah, and it took a couple tries proposing to NASA opportunities that were soliciting ideas for missions, but we got through on one of the tries, and it's the Pioneers program. It's what it's called.
Yeah.
And so Pandora was part of the first Pioneers selection, and that was, like I said, designed to be a 5-year development timescale through launch and science, and we're right on track.
Congrats.
Yeah, and so that's the one that should be launching later this year. So we're finalizing everything right now. But that's the one mission I've been involved with since the beginning, and it's been really neat seeing that develop. And it is technically the smallest mission I've worked on. Like physically, it's about my size. I would say I'm about 5 feet tall for reference.
So it's one Dr. Colón.
Yeah, exactly. So it's about as big as me. But meanwhile, things like, the Hubble Space Telescope are the size of a school bus. So, right, just to put it in perspective. Yeah, so it's a small, but we're hoping, mighty mission to study exoplanets.
Yeah, absolutely. Yeah. And it's getting spectral data, also transits?
Yeah, so it's doing things like, we have telescopes that study the atmospheres of planets, like Hubble and the James Webb Space Telescope provide really powerful data about this. But Pandora's unique capability is we're going to collect a lot of transits, like a lot of observations. So we're going to stare at planets for like 10 days, basically, and just get a ton of data on the planet, but also the star, and see how the star varies over that time. And so that's really the unique aspect is the wavelength coverage in both optical and infrared, but then also just that long time baseline that other observatories, it's just challenging for them to do because they're doing so much other science also. Yeah. And so, this is a dedicated exoplanet machine.
Well, I love that. I'm an exoplanet girly. I'm a transit girly. I love them to the bottom of my heart. So I'll be looking out for that for sure.
Awesome.
Do you have anything else that you would want people to know about NASA and the missions that you do here?
Again, it's just the variety is incredible. Like I mentioned, I can't even keep up with it because sometimes I do get focused so much on exoplanets and the infrared, like one specific wavelength, one specific topic. But NASA does, all wavelengths of light, they study everything, again, from the Earth to the most distant light in the universe that we can see. And so there's so much going on, and it's just really exciting every day. And I love the variety, and I love that, I get to meet not just other astrophysicists all the time, but even people who study the sun. I got to learn from them, and people who study the Earth, things I never thought about before, even though you think I'd want to connect exoplanets to the Earth, but
it's a different thing. It's a different bucket in our minds.
Yeah. And so, but we do take advantage of what NASA telescopes and facilities all over, rovers, we mentioned, International Space Station. Everything is just, it comes together to really just push us to the knowledge that we want to get to, and then the new development emissions is always really exciting to see where we can go next.
Yeah. One lesson that I'm always trying to give my listeners is that space is a lot more dynamic than we think it is. And now I'm realizing that NASA is also a lot more dynamic than people necessarily think it is. So thanks for that.
Yeah. No, absolutely. I agree.
Cool. Do you have any links or handles that you would like to share with the audience?
One where you can follow Astrophysics is at NASA Universe. There's tons of content there on, everything we're studying about astrophysics. And then nasa.gov/podcasts. You can find a lot of content there on all kinds of topics.
Very cool. It was really great to chat with you. Thank you for the support help that you've probably given me in the past and to everyone else. So I'm glad you do the work here.
Yeah, absolutely. Thanks for having me.
Of course. What were your general impressions of the day? Because we left pretty soon after this interview happened. We went and we had a lovely dinner. What did you think of your day at NASA? Eric, did anything surprise you?
I guess I was just like a little bummed out being there. Like this was very much, it was February 2025. We're here in the future. We know what was happening then. And, there are proposed budget cuts coming to NASA. And it was just symbolic, I think, of a lot of Americans' feelings about where we are at in 2025. We made plans in the summer of 2024, hoping it would go one way, and then it didn't. And now we just need to kind of soldier forth as humans. What are we going to do? Like, roll over and die? Like, I still have to be alive, and I still got to do the commitments that I talked about. So that was more just like the thing that was just tough to deal with. Even though we weren't even asking them anything crazy, they were very much extremely on their guard, which I totally understand.
Well, yeah.
And I feel like they had to, but it was a weird experience as being guests being welcomed in. It was like, I'm going to a party at your house and I can just tell that the people who work here just fought. Like there was just like a vibe there the whole time.
There's tension in the air.
Yeah.
It was there from the pre-planning call, which I mentioned before. My goal was to figure out like who the support people for NASA missions might be and like what all those teams look like. And I think I ultimately got there. I think Knicole and I had a great conversation and I learned a lot, but the fear that conversation could be twisted into a type of justification for what NASA is doing was hanging heavy over us in that room.
Yes. That was very much of like, we're being watched and just giving whoever to do whatever choices that they want to.
But it is really hard to see as a scientist the real-time consequences of making science political, because NASA shouldn't be of like any of the big science research centers, right? Like they shouldn't be, and yet they are, and so that was just hard to stomach. At the end of the day, NASA is a bureaucracy, and it is a government organization with roots in the military-industrial complex, and it is not as progressive as the general public wants it to be, and it never will be. And so that's just something that I was really like forced to reckon with. That is why I have never worked with NASA, and I never will unless they give me so much money. And I don't think NASA has that in their budget.
Get 'em.
They didn't
Fucking
before,
get 'em,
and they
Moiya.
certainly don't now.
Get 'em.
So with all of that said, I thoroughly enjoyed this day at NASA. I learned a lot. I'm glad that I got to see behind the scenes, especially of Nancy Grace Roman before she launches, hopefully in May of 2027. But I think that this is a good reminder that, organizations are not the like ideal versions of themselves that they publicize. I'm just going to keep that in mind.
Yeah. I want to shout out the Legos that we saw, the ladies in space Legos that were there. I really thought those were sick.
Shout those out.
Yeah.
Really made the tour special. Okay. Well, Eric, thank you for your part in arranging that. even though it wasn't exactly what we wanted it to be.
Yeah. No, I mean, it's not even like, I know I started out with this, but it's just like when I think about that trip, I'm like, wow, the world's changed a lot and it's not for the better, you know? And like, this isn't NASA's fault. It's just the way that we all needed to deal with it. And it just like, it's hard working with a government entity on its own and trying to organize a trip to get there was difficult enough on its own. And then at the last second, it's like, hey, so we're really worried about everything. So it's just like, I'm more disappointed that this is what it kind of shook out to be, honestly.
Yeah. Well, before we end, I would love for you to brag about yourself for a little bit. Tell us what you're working on and where people can find it online.
Yeah, you can find Join the Party, actual play podcast. We've been doing it for 7 years. I'm the best GM in podcasting, so you should listen to it. Season 2 of Attach Your Resume is coming out, where we do interviews with people who do digital things and have digital jobs. And we got some really interesting guests, including some from NASA and some really exciting other folks. I don't know. I'm out here. If you wanna do something, have me on your podcast. I'm really good. Right, Moiya?
Yes. You are really good. How do they get in touch with you, Eric?
Oh, you can find me on social media. You can find me on Instagram at L_Silvero, EL_SALVERO, my name if I was a Lucha Libre wrestler. I'm on Twitter. I'm on Blue Sky. Or you can email me at ericsilveratwork@gmail.com.
Awesome. Yeah, the links to your sites will be in the episode description. So listeners, check those out and listen to Eric's podcasts. I love Join the Party.
You do?
I do. I love it, and I recommend it to everyone who tells me they are into actual play podcasts.
Nice.
All right. Well, thank you for this walk down memory lane at the NASA Center. Any last thoughts before we adjourn?
Tradition, boop, 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 and then a rocket explodes. Like, imagine, play a song with a fucking beat.
Excellent.
Yeah.
I don't know enough about Fiddler on the Roof to make a real reference to that.
Sunrise, sunset, Moiya. Don't worry about it.
Sunrise, sunset. So, well, whether you're a morning or a night person, listeners, your space. You are. So bye. Pale Blue Pod is hosted by me, Dr. Moiya McTier, a.k.a. the universe's bestie. I created the show with original co-host Corinne Caputo, a comedienne extraordinaire, and help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen, and our audio editing is handled by the incomparable Misha Stanton. I am Go Astro Mo everywhere online, and you can stay in touch with the show and the universe by following Pale Blue Pod on Instagram or checking out our website, palebluepod.com. We are a member of Multitude, an independent podcast collective and production studio. So if you like Pale Blue Pod, you will love the other shows that live at multitude.productions. And if you want a shout out on the show and research notes for every episode, you can join our community over at patreon.com/palebluepod for just about $1 per episode. Thank you so much for listening to Pale Blue Pod. I'll be back next week. Bye.